Hello there. I hope you're doing well. Today we're going to look at chunked voxel rendering, or chunked voxel Raymarching, I think is what I called it. And to get into that, I want to show you first, actually I'll show you first what we got right now. Hopefully it won't lag the stream, let's see. Okay, it seems to be okay. No frames getting dropped. That's good. So as you can see, we've got this kind of interesting looking effect now. This sort of undulating terrain here, which is pretty gross. A few artifacts remain from the lighting, but overall I think it looks pretty much what I imagined. So currently we're only rendering one chunk, and if I walk outside the chunk, you can see it doesn't really work. And that's because we're using the sign distance field, which is only calculated for the chunk that exists, and we have nothing outside. So there's a couple of problems that we might run into. So let's imagine, for example, that we've generated a bunch of chunks, and we're just going to use 2D. We've calculated the sign distance field for the chunk. However, there's a bit of a problem. So for example, if we look at, I think the easiest example to look at is this one here. So let's say an empty chunk has a maximum distance, which in this case would be 4 because these chunks are 5 by 5. And that's what the sort of default value is if the chunk is empty. And well, you can kind of see right now, there's a problem right here. So if we're in this chunk and we're looking at this chunk, it thinks we can move 4 voxels. So we're going to jump 1, 2, 3, 4 to here, and we'll see this one. We won't see this at all. So we're actually going to skip past it, which is a bit of an issue. And there's another problem up here, a little bit more subtle, but this 1 should be a 0, because if we are standing here and we're looking that way, we move 1 unit, we're going to be inside of this voxel, and that's going to be incorrect. This should be a 0, but the reason it's a 1 is because it only accounts for its own chunk space. So I thought we'll just do the simplest thing possible, and we'll add one optimization, which is also very simple, and that's it. So what I'm going to do is I'm going to consider all neighboring chunks when generating these fields. So let's say we've got, we're generating this field here. Well, I'm going to check this chunk here and these 3 as well. So I'll check all 4. Actually, we're going to have to check 8, I believe, because if we had a square here, but we had nothing in these directions, then this would be incorrect. So we need to check 8 in 2D. So in 3D, that would be 26, I think. Yeah, 26 chunks. And that'll give us the result. But what's the optimization? Well, let's just say, for example, we're doing this one here, and we're just going to forget about the other chunks. We're just going to use these 3. The optimization is, let's say we're doing this voxel. We're calculating the distance. What we're going to do is we're going to walk up and through the other chunk and up until we hit something, and then this will be the distance. So we'll call that, I guess, y sub 1, something like that. And then we'd walk down, and then, well, we're not even going to check what that is, but we'd walk down, and that would be y2. And then we would walk, the other directions. But let's say left until the end here. That would be x1, or maybe this one would be x1 and the other one would be x2. It doesn't really matter. But the point is, we're going to hit this as x2. And then this would become, well, in this case, it's 1. Like the distance is 1 or 0 in the way that we store the data. So we're just going to take the min of all these as the first step. So we're going to check each cardinal direction. We're going to take the minimum as the first step, and then we're going to run a loop over that. So let me show you a different example, which will make it a bit more clear as to why this is an optimization. Let's say we're doing this, or maybe this number here, or this number here. Let's say this number here. So we go up here, we take this, we take, well, we'd have to go all the way through the next chunk here on the left. Let's say there's something here, so it'll be that. And then down, we've got this. So these are equally spaced apart. And then we get to the edge of this chunk over here, and there's nothing. And then we take the min. So the min is going to be either one of these. And that would be our second step. So then we would actually just check 1, 2, 3 up, and 1, 2, 3 to the side. So it would be sort of like this size here. And we would just check each voxel in this space here. So it's a pretty small optimization, but it means we get to skip all of these, and all of these, and all of these, and all of these. So we skip quite a lot. Yeah, it's pretty simple. I think it will work. Let's see, is there a problem where it may not work? If I grab this and I put it like here. No, I think it'll be fine because we're always going to check in that box anyway. So yeah, we'll see though. So that's sort of the idea. As for how we're going to do that, well, first we need to get multiple chunks in the game again. And then we'll figure out the next step from there, I suppose. So let's see. So in our main file where we're putting in the chunk data, where are we doing that? So we've got one chunk here, which is in the SDF storage buffer. So that's this. Oh, I should actually mention, I did make an optimization to actually get it to run at the speed, because I'm not sure if you watched the last stream, but if you didn't, it was running at such a low frame rate that or rather I should say, the frame rate was, I think it was acceptable. I think it was about 60, but the resource usage was so high that OBS was lagging, which is a bit strange, but that's just how it is, I guess. I think OBS takes on the graphics resources of anything it's recording. I'm not exactly sure how it works. It seems a bit weird to me, but yeah. That's what was happening. And so what I did was actually use an optimization my friend mentioned to me, which is we now send in a bit field. Instead of checking the texture, we just check this bit field for if it's a 0 or 1 in a particular position. And so we've got a function here, voxel exists, which is just sampling the bit field. The bit field has 128 uints because 128 uints in bits is 4096. So yeah, That's what that is for. And you can see the reason we're checking that is here. So Voxel exists. We're checking it in the map local function. Oh, that was also the calculate normal function was really expensive because it was sampling every single voxel. And now we're using just locals, which makes it much cheaper. And map local is actually just doing a 3x3 sampling, which is fine for most cases, although I think we are getting a bit of a messed up thing here in the lighting. I didn't make this flashlight. I asked Claude to make it for me. And yeah, I haven't had time to go over it yet properly. But you can kind of see the typical LLM comments where they comment everything here. Hello, Leonardo. How are you? We are working on multiple chunk rendering for this STF voxel stuff. So there's only one chunk right now. We're standing inside of it. We're going to expand it to multiple chunks and see if we can get this cool effect to look a little bit more realistic. That's what we're doing right now. So, as I was saying, we got the STF numbers, but that's just for one chunk. So, do we want to do a draw call per chunk? Are we going to have to use a shared depth texture, or I'm not sure. And thank you. I gotta stop eating these biscuits. Yeah. One packet of these biscuits is my daily nutritional intake. Well, not nutritional, but caloric intake. It's definitely not nutritional. All right. I suppose we will just add more stuff to this one. Let me see. We've got VKCMD draw. So we're drawing here, and it's Raymarching, right? So I guess there's no reason we can't add more things to the same buffer. Let's see. So the position is all based on what? Coordinates? Yeah. So we should just be able to add more onto the end of this, as long as we add it in the correct order, I think. Alright, so we're going to do that. We're going to try that and see what happens. STF underscore, what are we looking for? Buffer. Storage buffer. So if we go to here, this is where we actually generate the data. So I've got, no, this is the wrong one. Isn't it? Oh no, we're doing it in a compute shader. Yeah, we're still using that compute shader. I forgot about that. And then we're putting it into a texture. No, we're sampling the texture. Alright, this is how we make the distance field. But how do we make the actual data? Here it is. Noise, here we go. Okay, so we're currently using one chunk. But if I change this to use a loop, and I change this, and then I say this is just going to be 0 to 1. We should get 2 chunks. Yeah, I don't really like the styling here, but it doesn't matter. So that should give us 2 chunks in the scalar field. We need to make space for it. Okay, and then we use the scalar field here. No, we don't do anything. We're just looping over it for no reason. That's great. But we do use it here for just 1 chunk. This is for the bit field. So I suppose I need to do this as well. I need to update this. Alright, I'm just gonna run this, and it's not gonna work properly, but I want to see what's in the buffers here. I have a feeling it's not gonna work. Yeah, okay, it's just... Oh, that's interesting. Oh. Okay. Alright, let's have a look at the data. So in the pipeline, we should have a few buffers. I want to look at the test. I think I called it test for some reason. I really should rename these things. Yeah, it's called test. I'm going to rename this to SDF. Yeah. Okay, so I've got a bunch of floats and a bunch of bits. So I'm just going to turn this into a float array, maybe actually 16 floats at a time. No. Oh, I think I need to turn it into a struct. Struct. Actually, it's fine. Doesn't really matter. So we've got the floats. Some of them are 12, 13. That's all good. And then this is the end of the floats down here. Because... yeah, I did something stupid. So, this... I think it is being used, so we have to keep this. But this number cannot be the same because we just added another chunk. So of course it has to be the amount of chunks that are in the scene. So I could change it to 8192 just for now, and then this would be 256. But I don't think, maybe that's not the best idea. Let's see. I might be better off moving it to a new buffer. So we've got the bit field and a separate buffer from the floating point numbers. So I don't have to worry about the offsets. That's why I'm thinking that, because I've just sort of manually offset the data here, which is a bit error prone. Do these need numbers in the shader? I think if I change this to a struct type, maybe not. I'll keep them like this, okay. So I'm just going to make a new buffer. So layout. This is SDF bits, I suppose. And this one's SDF numbers, which is fine, I guess. Doesn't really matter. Okay, so that means this is going to be different. We're actually going to map to a different storage buffer. So I'm going to grab this, change it to SDF bit field storage buffer, and this one can be distance storage buffer, I suppose. I should rename them. That way I get all of the call sites renamed as well. Okay, we go down here. This is going to be just one chunk. Actually, it's going to be two chunks of float 32s. Okay, that's fine. Although I think I made an error down here because I allocated some space. No, that's okay. Alright, so we're going to need to make another buffer. Luckily I made this function for it, so it's less tedious now. Just 2 lines instead of like 20 lines that it was before. So distance can be bit field. So chunk total, no, that's not correct. That's not the correct number. What was the number? It's 128. No, I just put 128. Alright. I suppose that's how many we need per bit field. Okay, now we're going to have a problem with the compute shader, because the compute shader is using the SDF distance storage buffer. So if we look at the dispatch, we're just dispatching it once, and we're not. Yeah, that's going to be a bit of a problem, I think. So I got the group count of 16, but there's no we're just using the workgroup ID as the coordinates, which is only going to work when there's one chunk. Well, we could just use a uniform or push constants, maybe. Yeah, maybe that'll be fine. So push constant, and we're going to add in, what are they, uniform, that's all you need to add, and then actually just call it push constant. And this is going to be the coordinates, world position or something like that. Except it'll be a vec 4. I think even if I use SCD430, it'll be a vec 4. That's fine. So coordinates will be world pos.xyz plus this. And that should be good to go, I think. So that will mean that we sample into a different spot in the buffer here, which is not a vertex buffer. This is actually SDF distances, or distance or something. That's fine. Assign distance field distance. Yeah, I guess. Okay, so now if we dispatch another one, but with a different push constant, which we actually need to do for the first one. So I'll grab this, put it here, push constant, command buffer. It's the compute pipeline layout. Where is it? Oh, it's local here, isn't it? Yeah. I never made this a state variable. Okay. Layout compute. It's going to be 1 vec 4. And I'll just make a little variable here called push constants, which will just be a vec 4. And it will be, no, 0, I guess, for the first one. Okay. And this one will be PC equals, let's just say on the x-axis, 1, 0, 0, 0. Okay, is that going to work? I hope so. I don't know if this will actually work. Of course, I'm still missing a bunch of stuff, so let's just see how broken it is. Okay. Oh yeah, I didn't actually create the pipeline with push constants, so that's a bit of a problem here. Create pipeline. Oh. Wait a second. Where's the push constants in here? Are push constants even available for a compute pipeline? I don't know. So stages, colorblind, dynamic, multiple. Okay. Push constant ranges. So it's in the layout create info. Alright. So that should be here. No. Descriptor layout. No. Pipeline. Oh, here it is. Okay. Push constant range count equals 1. Push constant ranges equals push constant range. Okay. And I can't do it like that. I can't remember what the values are, so I'm going to have to make this a variable. Oh, I guess I could just look at this. Okay, it's this stuff. So we've got stage flags, and we're just going to do compute, and offset, and size. Oh no, we need the size. Size is size of back 4. Okay, we've got another crash. Oh yeah, binding 3 SDF bits is not available. Yeah. So we need to go back up to this pipeline. SDF config, here it is. So we've got the distance storage buffer here, but we're going to have to add another one for bit field, and the binding is going to be 3. And I believe we have to add something down here. Where is it? No. Or is it up? It's up here. Here it is. Another storage buffer, another binding. There we go. Okay, that's good. Now we can see some stuff, and there are some voxels over there. And the Raymarching is obviously not working. It's interesting that the world seems to be different. Let me have a look at the texture. I want to have a look at specifically. Where is it? Actually, I can probably just look at the resource inspector. There's only one 3D image. Here it is. So this is chunk 0. And if I look through the slices, it looks pretty different. I don't think I used a different seed though. That's weird. So basically this is different somehow. The scalar field. Hmm. Oh, this is different. It should be... Yeah, it should be like this. Chunk height times height and CZ times chunk depth times Z. Okay, we got an error. A bounds error. So this scalar field is not big enough to fit these things. That's interesting. I did make it large enough to fit 2, and then I generated 6. Okay. Yeah, let's just generate 2. Alright. Now it's different again, which I guess I would have expected. Yeah, that makes sense. But the thing I don't understand is why it's different from the original chunk. So if I just oh, this is still not 2 chunks. I'm stupid. There we go. Wait, what's the problem? Oh yeah. CY is going to be 0, CZ is going to be 0. Okay, is that going to work? Yeah, interesting. Well, if I make another copy of CX in here, what happens? That's very weird. Oops, I made a copy. I meant to make a copy that's 0. I can't shadow it, and I probably can't set it, right? Yeah. What if I just set this to 0? I just want to see if this will get me back to the same state that I was in. No. What's wrong with this? Index from coordinates. This gives me index in a chunk. Yeah, this is wrong. That's why. I think. So the problem is, when I index into this array, it only holds 2 chunks. So maybe what I should do is just do the really stupid thing first. And copy this line. And this line, I guess. Oops. Grab this. Get rid of all of this. Change this to X, Y, and Z. And this as well. Okay, and then just copy it and paste it, and then make this 4096 plus. And then this would be x plus 16, and then everything else would be the same. Yeah. So, a little bit silly, but don't really care right now. Just want to see if things can work. What does that look like? Okay, that's better. At least the first chunk is rendering as I had it rendering previously. It's interesting that the Raymarching still doesn't work. There's probably something wrong with the other code. Oh yeah, I'm not actually uploading the data. So this is going to be totally wrong. This should be bit field, and it should be like this. Warren says, commands like CI will let you change everything in a ... expression and not require deleting every character. Oh, like CI? I think that might be a Vim command. It's probably the same thing for this editor, but yeah, thank you for letting me know. I don't know what it is though. So CI is change inner, right? So I don't think they're called the same thing in Helix. It's probably select. Inside object, like mi. No, m delete, like that kind of thing. Alright, anyway. Where were we? Okay, so I just deleted this, so it should be at the correct position in the data now to write the bit field. So I guess. Alright, cool. We've got the undulating stuff back, which is nice. It's a bit of a weird effect up there on the edges, which is probably not a problem because we're not going to see edges once we have more chunks. So that's fine, but we don't have two things drawing, and that's because, well, I don't know why. Let's think about it. When we're drawing two chunks, I draw the chunks rasterized first as cubes, so that's what this is. So I've got chunk total. This should be chunk total times 2. Let's see if that draws the white rasterized version. No, I don't see any more of them. Okay, which way is X? That way, or that way? Now it's possible that this this shader is not set up properly, although I thought it was. World position is chunk positions. Alright, so there's a binding called chunk positions that I need to put data into, and I think I haven't done that. So let's do that, shall we? Chunk data. Is that in the context? The cube, voxel data image, uniform buffer. I guess it's the uniform buffer. Yeah, we never put any data in there. Okay, let's do that. I don't know why there's 512 values. That's 8 by 8 by 8, right? Oh yeah. I was drawing that many chunks a few days ago. Okay, we'll just put something here. Chunk positions, not cunk. For some reason that sounds like a slur of some kind. So we're gonna put in here, what is it again? Uniform cube uniform buffer. Okay. And we're just gonna say these are vec4s. Data 1 equals 1 0 0 0. I think that will suffice. This needs to change. Right. Well, let's look at render doc. We'll look at the triangle drawing. Right? I think so. Oh. 8,192 bytes needed, 16 provided. Is that a problem though? Apparently. Chunk positions 1 is 0. Oh, that's not good. Let's see. Cube uniform buffer size. Ah, yeah, that's totally the wrong size. Times 512. Yeah, of course, 16 bytes is just one vec4. Whoops. Okay, now we've got data and we have... Okay, we've got chunk positions in there. That's great. So that's good. I'm seeing something a bit weird here. Maybe it's just my imagination, but no, that looks alright, I guess. Okay, so we're not getting the other chunk drawn. Why? Oh, we're getting encoding overloaded. Damn it. That was in OBS, I mean. So OBS is not happy about that. Unfortunate. Alright, so this is definitely going into the buffer. Okay, then we bind the pipeline. We do the blah blah blah. We draw apparently enough to fill 2 chunks, but that doesn't seem to work. Chunk positions, chunk index, it's the instance index. Now this is the world position of the cube. Is it? Hang on. Yeah. Oh. This is a bit of a problem. Okay. Well. Okay, we've done something a bit dumb. But I'm just going to say data. That's why there were so many. For I in... How many were there again? 512? So this chunk index is getting the instance index, which is going to be between 0 and 4096. Dividing it by this number, which is... Isn't that also 4096? Okay, so if the instance is, let's say, 2000, or 200 even, 4096, then I get this number, which is going to be truncated down to 0. That makes sense. Okay. And then if we're at above that, so the instance is like 5000, we divide that by 4096. Of course, we get above 1, which is going to be truncated down to 1, which means we should be indexing chunk positions 1, which contains x, 1, z, and y and z are 0. But are we using this world position? No, we don't use it. No, we do use it. Oh yeah, and we flipped this because of the way I had it set up before. So let me see if I can find the old code on GitHub. So it was just before when we had 8 chunks working, rendering multiple chunks. Probably this one. Okay, alright. Oh, damn it. The lag is real. Okay, so I need to find where we actually set the data. So it's going to be around a fix me, I think. Next one. Okay, so we've got sunlight matrix, some lighting stuff. Here we go. No, we were just drawing shapes at those chunk positions. Debug UI, no. Oh, this is in the main loop. So it's going to be above that. Okay, chunk index equals... Oh yeah, I was doing it in the same loop. Yeah. Which I think is not allowed. Hello again, Derek. How are you? Sorry, I had the chat closed for a second. I don't know when you said that. um, yeah. Okay, so we can just. I think this is not allowed to have the memory mapped memory overlapping. I actually had a crash in this version. It would happen after maybe 30 or 40 seconds. And so when I removed like 1500 lines of code, the crash went away. But one of the things that I saw was that apparently this is not a good idea. I'm gonna listen while driving. Oh, thank you very much. Where are you driving to? We've got the uniform. Yeah, okay. So chunk times width, chunk times height, chunk index times depth. Oh, so it's actually, all right, I got it. That makes a bit of sense now. So this value should actually be 16, not 1. Is that gonna change anything? Yes. Okay. We're drawing the same chunk twice, which is not really what we want. That's fine. That's probably just, well, maybe a bunch of things. Back home from your girlfriend's place. Okay, nice. You're in dead traffic. Right. Does that mean bad traffic, or does that mean no traffic? Because usually when something is dead, it means there's not much of it. Or it could also mean it's not moving, I guess. Okay, it could be a problem with also the scalar field generation here. So no, I don't think it is. It could be a problem with sampling the scalar field though, which we do in the cube, and also when we make the, oh yeah, this is not great. We only have one 16 by 16 by 16 texture, which we're using, I believe. Okay, in, where is it? Okay, let me look in shaders. Cube. Right. Yeah. So we're actually checking the texture here in the fragment shader. We don't actually need to do that. We can use that bit field that I made instead. So go into the cube vertex shader here. Where is it? It's not even in the vertex shader. It's in the fragment shader. Cube.frag. We got this voxels here, so I'm just going to put in another binding for a uniform buffer. Actually, it's a storage read-only buffer, so buffer read-only. What did I call it before? Voxel bit field or something? SDF bit field. And it's just got a bunch of uints in it, so it's gonna have 256 at the present. Although you don't actually have to specify a size, so I'll just put an array. Yeah, but the thing is, here we were sampling the voxel coordinates, which, that's interesting. How is that working? Yeah, okay, thought so. Okay, so that's all fine, except we don't want to do that anymore. We don't want to use that texture right now. We're going to say if, I got to get the other shader. We've got the bit field index, there we go, voxel exists, here we go. Voxel exists. I guess we need some kind of position. So I'll use the same variable, but it's going to be different. Then do this. Set the out color. Otherwise, discard. So we don't draw anything there. Now the problem is, this doesn't have any kind of offset, so it'll work for the first voxel. We'll have exactly the same problem. So even though our bit field has more values, although does it actually yet? Did we do that? Where is it? Scalar field. We added stuff to the scalar field, which is the floating point numbers. Yeah, we didn't do that yet with the bit field, so I'm just gonna change this. X plus 16, index from coordinates. I mean, is that just gonna work? Maybe. What index do we get back? Bit position. Well, I guess we'll find out. Right, yeah. Can't just leave this, can't leave this shader with code that doesn't work. So index from coordinates is not a function. In here, we've got to grab it from this file. There we go. I might actually make and include, can I do that? Common.glsl, is that a thing I can do? I think it is. Voxel exists, no matching overloaded function. Yeah, because this is actually the wrong type. So I'm going to say we're passing in an ivec3, but actually I'll do that in a second. I think we can just cast it. Alright, so chunk 1 is still working fine, or chunk 0, I guess. Alright, so the voxels are not rendering. The rasterized ones. The Raymarch ones are still fine. So, well, that's because we just broke this shader completely. So if we go to cube.vert, this is going to be wrong. We'll just do out voxel chords equals. I will actually pass in ivec3, x, y, and z, which doesn't use the world position. We need the world position. Yeah, okay. I've been thinking, since this game is supposed to be a single player horror game, at some point I might want to just figure out how big the world's going to be in 3 dimensions, and then just make the code run for specifically some size like this. And that way I don't have to worry about infinite chunks or anything. But maybe that will not even be too much harder. We'll see. So these coordinates need to be world pos plus. I suppose I could do world pos plus vec3 xyz. So these voxel coordinates are now in world space, which maybe I should change the name to. But see, I don't know if these functions work in world space. I can just make them. Shouldn't be too hard. Alright, so we're not drawing cubes. We're not drawing cubes because why? Oh, because we're not even passing in this bit field, right? Yeah, I just didn't see it because I'm printing numbers all the time to the console, which is the delta time, so I could check the frame rate. But we don't need to do that right now. Let's just get rid of this. Wait. Not that. This one. Alright, so we got an error, which is... Let me just pause this. Yeah, binding 1 was not set up with the correct resource. Yeah. Okay. Alright, so we can use the exact same buffer, which is cool, but we need to go to the cube pipeline. Here it is. So we create the cube pipeline, and then we make another buffer here, which is storage buffer. Storage buffer binding 2. The buffer is going to be SDF. Oh, whoops. I want to select cube uniform here. It's going to be SDF bit field storage buffer. Okay. Now I'm going to add something up here. There it is. Descriptor. Same deal. And it's available in the fragment shader. I think that should be good, and I don't think I need to do anything else. I think that should just work. I mean, it should just give us access to the buffer. Now something else is wrong. Buffer is null handle. I haven't created that buffer yet. Damn it. Okay. So this pipeline was made first, I think. So I need to make the other storage buffer. Hey, Anton, how you doing? So we want to get the bit field buffer available a bit sooner, so we'll put that up here. In fact, maybe I'll put it all the way at the top. I might just create buffers before pipelines, because that way if we have any shared buffers like these, we're not going to get this problem again. Okay. Alright. Still not drawing the cubes. Let's see. Oh, I didn't look at those in error. There is an error. Doing well, pushing through the last hours of the game jam. Oh yeah. Gotta go to bed soon and get some sleep before preparing. Nice. That's great. Why is there a media encoder opening on my computer? What the hell was that? It became a buggy mess with way too little time to refactor things. But hey, it's a game and not at all what the first plan was. Yeah, that happens in game jams quite a lot. At least in my experience. Yeah, send me a link, or just put it in the chat if you're comfortable with that when you're... Oh, it's not submitted yet, so you can't. But yeah, I'd be interested to see it, for sure. STF Bitfield. Oh. I'm unmapping the memory without being mapped. Oh, I didn't even read the error correctly, did I? It's actually got to do with this. I'm unmapping the distance, not the bit field. Send it on the Discord once it's ready. Cool. Nice. You learned so much from it. I'm so happy with that. Nice. That's great. I might turn down the resolution of this game, so it stops lagging the stream. What's the problem with this? Handle, blah, use descriptor, binding 1, STF bit field, but the descriptor binding was set to vertex bit. Oh. Okay, so storage, buffer, here it is. So we were looking for the STF bit field buffer, but not that one. Is it this one? No, it's in the cube pipeline, right? Binding 1. Okay, this is supposed to be binding 1, not... Oh, I see. How is Vulkan treating me? Are things falling into place? Yeah, actually. It's really... I'm not going to say it's not hard. I don't think that's really the right way of describing it, but the period of being absolutely overloaded is over. I think playing with the SDL3 GPU API actually helped with that quite a bit. Okay, what's the problem now? Right, I can't set the binding to that number. Okay, that's fair. I'll just set it to 2. It's not really a big deal. I think. Let's see. Cube.vert. So I've got location 0. That's the out. Parameter binding 1. Binding 2. Yeah, I'll just set it to 2. No big deal. Okay. Okay, there we go. We're drawing the cubes. Great. Cubes are being drawn. Of course, the chunks are still the same, it looks like. That looks a little bit out of place, doesn't it? Am I just drawing like the same chunk but one layer lower. Looks like that, actually. Yeah. It's funny how I had all this stuff working a few days ago, but now it is broken. Yeah, probably this function doesn't work correctly. Also, maybe the bit field's wrong. Alright, we've got about 45 minutes left. I really want to get this going. Oh yeah. I remember now. I looked at this before and I was like, okay. This is like almost full. This one is full, but I can't really tell much else from these bits. There's a lot of empty space. And in fact, it's all zeros after. So that means we're not updating. We're not updating the bit field correctly. At least we know that much. So where is the bit field storage buffer? Here. So this is totally incorrect. As I suspected. So index from coordinates. How do I get this? I think I'm gonna have to lay it out. So I've got like, let's say 4096. Let's make this not red. Bits, which are X, Y, Z. You did your first A* implementation and it was a pain to deal with coordinates, mapping, world and grid. Yeah, world, grid, screen, etc. Yeah, it can be. Especially when you got to map it back into one dimension. Well, maybe it's easy for some people, but I guess I don't have enough experience with it yet. So I got 4096 bits, which are the X, Y, Z coordinates for one chunk, and then we've got another 4096 bits. Right, so how do I index into 1D space, making sure that if I pass in an X, Y, and Z that's outside of this range, I get correctly starting into this range. Well, let's look at the current implementation. Take care. Alright, take care, have a good night, sleep well. Good luck with your submission. Alright, so the current implementation is pretty straightforward. First we go along the x-axis. So that's what, if we have a different x position, then we're, I guess, more left in the array, plus y times 16, plus z times 16 times 16. I guess, if I think about this, we could do something like world index, not even world index, but we could do something like cause.x mod width plus chords.y times, no, mod height. No, that's not going to give us the right result, is it? Oh, I have an idea. We can just do the same thing. I think we can do the same thing, but then we mod it by 4096 to get the offset. So offset would be chords dot. Actually, we could just do the offset after, I guess. Offset is index mod 4096. No. No, that's not going to work. I mean, that would work. That would give us the offset, but then the index would actually be offset plus chords.x mod width plus, see what I mean? Like the index into the local index. So this would be like, hang on, would that just give us the wrong result? God damn it. Why am I so stupid? Okay. I'm just going to do a quick test with the calculator. So let's say we're at position 17, 17, 17. We know that's outside the first chunk. Actually, 17, 0, 0. Make it easy. 17 plus... actually, I'll just make this function into something I can run in my browser. Index from coords. How do you make functions in this again? X, Y, Z, and it returns this. So X, Y, Z. Okay, so index from coords 17, 0, 0 gives us index 17. What? That's totally incorrect. Did I miss something? Or was my thing just broken this whole time? X plus Y times 16 plus Z times 16 times 16. So since these are 0, we're just doing 17 plus 0 times 16 plus... I mean, I guess... that doesn't make any sense. So this only works for local coordinates. Because 1600 would be right. And then 16, 1 is 32. That makes sense. That makes sense. 16, 2. I'm not gonna pretend that I can do that in my head. That makes sense. Okay, so obviously this function is not going to work for global, which means we need one that does. So if I put in something like 17, I want the result to be 4097, or 4096 actually. Okay, so let's work from that, I guess. I think you can write functions like this, right? X, Y, Z, I can just reassign this, I think. So, return. Well, if it's 17 on the X, it's going to be in the next chunk. Okay, I think this is, I'm trying to do two different things at once. Maybe there's a better way to do this, which would be something like chunk offset by coordinates. Let me have a look at this. Get chunk, no, get voxel position in 1D array. I'm sure a million people have done this already. How to handle massive numbers of chunks. Use a 1D array of storage. Yeah. Find generic item in 1D array based on world position. How do I access them? You don't need a new way of storing them, you just need a new way of accessing them. So, the world should contain a list of chunks currently loaded, and the chunks contain lists of voxels. Each chunk should be the same size. Okay, you have a 2D world where they're 10 by 10. You want to access 342 by 102. You need to find the chunk that contains the data. You can easily find that because you know each chunk contains 10 by 10. Oh yeah, we just divide it. Okay. Giving you 34, 10. You see, you get the coordinates within the chunk. Right. Wow, okay. That's easy, I think. So from coords equals X, Y, Z. Okay, return. So it would be X divided by 16 plus. Okay, this is going to be a problem again. This is going to give me the chunk. Hang on, let me read that again. God, why is it so hard for me to get my head around this? Okay. Divide the number of pixels per chunk, giving you chunk 3410. Okay, now I need to get the coordinates within that chunk. Now that doesn't actually help with the 1D version though, which I guess is where I'm getting stuck, but you could just multiply, I guess, 34 and 10 by 10 and 10, which would give you the original values. What, so if I add them together? Okay, octree, no, that's not what I'm talking about. These guys are talking about dictionaries. There are some great tricks, like bit shifting the XY coordinates to get an index. Oh yeah. Apparently the Minecraft page has some. That's a weird thing to ask someone. Are you an adult or a kid? On a Minecraft website? Maybe not, I don't know. Okay. Let's talk about the simulation distance and stuff. I'm kind of just interested in the indexing. Oh, here we go. The player can know the chunk they're in by this formula, x coordinate divided by 16. Yeah. Okay. Well, this page doesn't actually have the information that I'm looking for, I don't think. Okay, let's just try to work it out. Alright, so this is going to give me the chunk. And then if I add those numbers together, multiply them by 16. Why would I divide by 16 and then multiply by 16? It doesn't make sense. I guess I can just mod them by 16. Let me see. X. Actually, I'm gonna make a real simple thing. 17 mod 16 is 1, right? So that's gonna mean that we should move one chunk across in our 1D array, at least on the x-axis. So that would be plus 0, which would give us 1, and then I'm going to use a different chunk than 1700. It's not... there's too many zeros in there, so I could get the wrong answer if I put in the correct thing. So 33... Okay, so this is the internal index, which... I'm not sure if that works, but if we do... Okay, 17 mod 1 and 1 mod 1. What the hell is that? 1 mod 1 is 0. Wait, what? How is 17 mod... Oh, sorry. 17 mod 16. 1 mod 16 is also 1. That makes sense, I guess? No, it doesn't. Am I using the wrong mod? Is this mod the same in JavaScript? Yeah, it's the same, I think. 1 mod 2 is 1. 1 mod 16 is 1. 17 mod 16 is 1. Alright, so the point I'm trying to get at here is if I add the numbers together of these results, 1 plus 1 is 2, then I would want to move crap, I lost it. Oh look, this looks useful, maybe. Using 3D arrays is very, very bad. There's a lot of wasted memory. Okay. No, this is just a performance post. It's mostly about storing them in tightly packed arrays rather than sparse data structures, which I guess makes sense. Use 3D coordinates to index into 1D array. Yeah. Okay. Z times Z max times Y max plus Y times Y max plus X. I mean, that's what we've already got, except for one chunk. So this is just talking about It's just the same thing that we already have, but without the chunk element. Yeah, they got the same kind of problem. Okay. Same answer. I've done this before, you know. You wouldn't believe it, right? I'm pretty sure it wasn't hard. I think actually usually I stored chunks in... Yeah, I'm pretty sure I used 1D arrays, and then I would get the index of the chunk, and then I would get the index maybe offset from that. So there could be like chunk index from coordinates. Which would just be... Oh, what would it be exactly? You do chords mod chunk width, right? I'm pretty sure I should be using chunk width here instead of straight 16. Oh, that's chunk. No, this should be width. Width and width and height. Okay, coordinates mod chunk width. That's going to give us the x offset. And then y is towards, sorry, it should be dot x dot y. Chunk height, I think. Oh, no, it's going to be the same thing as this. Times chunk width plus. But I think I want local coordinates, do I? No. This is not actually correct. What am I trying to do here? Get the chunk index, right? The chunk index would not be the same as this, because these values must be modified, and this chunk width, chunk height thing doesn't make sense. It would be world width and world height, but we don't know that. So it would be a divide. Maybe divide. Chunk x divided by chunk width. That's for the x position. For the y position. Chunk y divided by chunk height. And then for the z position is going to be chords.z divided by chunk depth. But the thing is, we don't know how big the world is. But does that matter? If the world starts from 0, 0, and let's just say that it does, it only goes positive, well then the only way we can get the actual chunk position in the 1D array is if we know one of the lengths of the world, which is kind of what we're missing here, because we don't know when to wrap around, basically. So we don't know when the we know how big the chunks would be in storage. That'd be 4096 bits in the case that we're dealing with now. But that doesn't tell us the offset. So we need to come up with a world size. Or you'd have an associated data structure of some kind that would tell you the index into that array for a particular chunk. I'm starting to see why a lot of implementations I've seen, they store chunks in their own buffers. So they've got a separate buffer for every chunk, and they've got a separate mesh for every chunk and stuff like that. Because then you don't have to worry about this data alignment problem. And especially for Minecraft, since the world is infinite, you would have to go based on render distance, I guess, but then if they're loaded in the wrong order, because multi-threaded, you wouldn't really know, so you have to have a map or something that says, okay, I'm going to put, for example, chunk 1 is going to be at, you know, in the bit field, in this case, bit field, offset 4096 is going to be the first one, and chunk 2 is going to be bit field 8192, etc., etc. Okay. Well, we only have 2 chunks right now. So can we utilize that to our advantage somehow? Probably. 1 chunk, 2 chunks, 2 chunk. I mean, second chunk is the same as the first chunk. We've just offset it slightly. So this is not going to work. The thing is, this should work. The scalar field should be full of floating point values, which is fine. It's the bit field that doesn't work. So this would be, I guess, 4096, and I'll just leave that as this, plus blah, and then this is divided by 2. Yeah, I think that'll work. Let's see. Well, no, that did not work as I expected. Let me have a look at the memory. It's not 4096. That's totally wrong. It's going to be 128. Wait, no, we do divide it by 32 here. Okay. Okay, the data says what? Here's the bit field. Let's go to 128. Okay, we've got numbers in there. And they're not the same as the other chunk, which means most likely this is working now, which means the next step is the sampling. So the sampling is not working. This voxel exists. Yeah, this is a problem. So I'm just going to do a really dumb thing here, I guess. I'm going to say if in world voxel coords.x is greater than or equal to 16. Then I'm going to do something else. I'm going to do this thing that I just did. Alright, so I'm going to grab this. Basically just going to put it here. So I'm going to say the index is going to be 128 plus this value. Okay, and now we can say if this bit field is not equal to 0, then out color equals 1. And I'll just copy this line here, else discard. I think that's right. Okay, coordinates are not a thing. That makes sense. Okay, coords. I thought this was an IVEC3, wasn't it? Did I not change that? Cube, but there we go. I didn't. Okay, line 21. Apparently this is a not unexpected, not equal to. Oh yeah, right. You need to put parentheses around if conditions. Well, that definitely looks different, but a little bit weird. Maybe I don't need to reverse this anymore. Let's see. Oh, definitely not correct. Okay. Well, let me have a look at the oh, I didn't make a second texture, did I? Definitely got 2 of them here though, which is nice. The Raymarching does not work though. Why is that? Probably it's set up to only work with 1 chunk. Oh, I don't need to look at that one. I need to look at the fragment shader. Okay, so I've got kind of the same deal here. It's all indexed from coords. Sphere trace with binary search. Oh yeah, that was another little optimization that I found. Which is basically when you get really close to the edge, you might go inside of it, and then you want to reverse a little bit and then do a binary search to find the surface. Okay. What am I looking for? I guess the map function, right? These are only designed to work with single chunks as well. Even map local. Like the min and the max is an index of 15. So this would be more like 15, 15, but if I change the x-axis to be 31, will that help? Maybe. Am I still using map for anything? I don't think I am. No, I'm using local for everything now. Let's comment that out and have a look. Oh. That's kind of cool. Lagging the stream again though. Well, quite a few issues. I'm a bit concerned about the performance of multiple chunks. I think maybe a better thing to do, or maybe just better for my sanity, is to actually render the chunks in separate calls, but make them share the same depth buffer. So that way I don't have to do any of this indexing into the 1D array in the right world position, which is quite difficult if you don't know the world length or width or height. I'd say it's basically impossible. I suppose, unless you, yeah, you can't do it without one of those values or two of them. And then doing these calls in a separate render call, and then compositing them using a depth buffer. So that we do have a depth buffer here. It's called the. No, we don't. We don't have a depth buffer. That's right, because we're Raymarching. So we're basically going to make a depth buffer in the fragment shader, I think. And then share that between calls somehow. I'm gonna have to look into it for the next stream. But yeah, also I was thinking, let me just, I'll see if I can tone this stuff down a little bit. Actually, maybe I'll just make the window smaller for now. So this is going to be 540 and this is going to be 860? No, 960. Tiny window. Still getting overloaded, wow. That's crazy. Okay, well, let's see, max chunk size, was it? Chunk total. I'm looking for chunk total. So I'm basically looking for, actually I'll look for this. Just gonna draw the one chunk. And then go back to here. The cube shader, that's fine. The cube shader doesn't really have a big performance cost at all because it's all instanced. I just need to look at this one. This is okay. What was the problem? Okay, it's still drawing all these different chunks. I can't remember where I changed that. I just did it though. Oh, yeah, it was in the map function, right. Map local, there it is. Okay, thank you. Yeah, there's a problem. Unexpected semicolon. Alright. expected right paren. Okay, there we go. We are still getting encoding problems, so, oops, that was supposed to be 15, but I'm going to change it to 7. So maybe we can get less laggy. No. It seems like as I open the program more, OBS gets more laggy, because at the beginning it wasn't laggy. And we're not doing anything too crazy different. I mean, sure, we've got a little bit more data that we're uploading at the beginning, but that shouldn't affect the frame rate. So, not sure what that's about. Yeah. Well, anyway, I was going to say, I kind of want to mix rasterized geometry and Raymarch geometry. So if we have a look at something like, what are they called? Something nets, surface nets. You see, I've already Googled it. You can get some pretty interesting looking shapes like this, which is kind of what I want, sort of low poly-ish looking shapes. And then this will be really, really, really fast to render. And then the spooky stuff in the game could be Raymarched. It could be an idea. Because as you can see, I mean, as you've probably already seen if you were looking at the stream, the cubes render behind the Raymarch stuff. And, you know, we could do something like that, like this, and then the goopy stuff could be on top. I'm not sure. I don't know. I want to keep messing around with it. It just sucks that it lags the stream, because I want to do most of the work on stream. And then, well, that's just not a very good outcome for anyone. Because I don't know if it lags the audio. I suppose I should check that. But yeah. It's kind of what I'm thinking. Also, as I sort of alluded to, I'm not above lowering the resolution, since I'm going for a sort of low-ish, lo-fi look. So I wouldn't mind lowering the resolution and just upscaling the pixels, which would be much cheaper. It's like a quadratic reduction in processing for Raymarching, because, you know, you reduce the width and the height by half, so it's a lot less of fragment shader that needs to fire off. But yeah. Yeah, I'm probably going to move to, at least for now, I will move to the separate chunk solution. So each chunk will draw itself. Well, that's not really the right way to say it. That sounds like oop. That's not really what I'm talking about. Each chunk will be sort of contained, have its own buffer and stuff like that. And then they can be reused when they're not currently in use. I think that should be fine. So we just allocate enough space for the maximum amount, which does mean wasting a lot of VRAM. There's another thing actually that I wanted to look at to get the speed up a bit, and I'll sort of demonstrate what that is here. So right now, if a chunk is solid, then, right now the chunks are solid, but basically I was thinking it could be much cheaper for everyone if the chunks were cut like this. So you've just got kind of a shell. Maybe it would be including corners, inner corners like that. And the reason is because then we could skip updating these, or skip using these in the calculation. I'm not exactly sure how it would work. Why did I think that would be faster? I don't know, I had a reason, but I don't remember what it was. It would only work with, I think the optimization I was thinking of would only work if the concave, so maybe that's not going to be viable. Because, for example, if you had a chunk like this, kind of U-shape, like this. Maybe I'll put this here. You know, I was thinking something like, actually even just like this. If we just had this shell like this, that might be, actually that might be fine. Then we'll just Raymarch until we hit an edge, and then we wouldn't consider anything inside. So none of these ones would get Raymarched. But we kind of do that already with Raymarching, so I don't really know what the hell I was thinking. I don't know, I just had a thought of it. It was yesterday. I didn't write it down, so now it's all jumbled, which is not good. Maybe there was some reason for it. Don't know. The other thing is we don't have to represent the whole thing in memory as we currently are. We could have the bit field, which represents whether something is there or not. And then we could have basically sparse data. So we could, I guess, use an octree, which I believe would help a lot. But it kind of fulfills the purpose of this SDF thing that we've made here. So if this SDF doesn't exist, then we could use an octree, which would basically, as far as I understand, cut the geometry into 8s. But let's just do it in 2D first. So we'll do it in 2D, and we'll say we've got, I'll just grab some voxels from here. We've got some voxels here, and here, and maybe they're not quite aligned, but I'll try to get them roughly aligned. Something like this. So we're going to cut the geometry in half, and then in half again, and then this, there's nothing in here, so this is going to get marked as empty. But since these three have stuff in them, we're going to cut them again into 8s, well in this case into quarters because it's 2D, but now these are all marked as empty, and we've just got this one here. And then I think this one would get cut as well, and then these would get marked as empty. Of course, we probably wouldn't do it on, we'd probably keep it on voxel boundaries. So I would say that would be one, you know, maybe that would be, this would never happen actually. Just this shape wouldn't happen because we don't have that shape in the chunk. But anyway, let's just pretend that's one voxel. And then let's pretend these are actually 4x4 grids here. And so these would get marked as empty, and then these would get marked as empty, and then this would be full. And that would mean at any time we can, if we're standing here and we shoot a ray, we know that we can go to the bounds of this thing at least, and we can go here and we can check, okay, now we're here. Is there anything in this quadrant? No. Okay, I can shoot to here. Okay, now I guess it depends which one you hit into first, but let's say you hit this one. So it's a bit of a off array. Actually, I'll do it like this. So we go down, we hit here, we're like, okay, we're in this quadrant. Is there anything there? No, we go down. We hit this. Is there anything in this quadrant? No. Okay, that means we can step this far. And now we're here. Is there anything in here? Yes. Okay, now we're going to do the full Raymarching thing. So basically, it's like this, but you don't have the exact number from any position, which means also you don't have to store all of these numbers, because this is just saying, you know, between these positions there's nothing. So I'll look into this as well. This is a pretty common thing, octree. There's also other structures we can use. And maybe if I get the performance up high enough, we can continue working on it on stream, because yeah, just not really good experience for the stream to be lagging. All right, that's about it. We didn't achieve the goal that I wanted to, which I didn't really even I did explain it here. I said we're going to do an optimization, but we didn't do that because we didn't even get the second chunk up and running. So yeah, we will sort that out, and I'll see you. What day is it today? I'll see you in 2 days. So I won't be on tomorrow, but I'll see you in 2 days. Thank you. Cheers.